action platform, including a governance dashboard where administrators can configure AI prompts and various scheduler interfaces. This also allows defining business rules without any code changes in the MCP server code. Let's look at the governance and autonomous execution. The display you're seeing now is our governance and autonomous execution dashboard. This dashboard serves as a single source of truth for all business rules. For instance, our scheduler periodically identifies sales orders with billing or delivery blocks and validates them against configurable conditions, such as a net amount threshold, before releasing them. Critically, any rule updated in this governance dashboard is immediately applied across the entire solution. Both conversational AI and the autonomous scheduler use the latest configuration for all future executions, ensuring consistent business decisions without the need for redeployment. Now, let's see a live demonstration of how our sales AI agent works and how it handles end-to-end sales order lifecycle processes via live user interaction. Afterwards, I'll also show you how the agent governance dashboard functions based on autonomous scheduler actions. Let me start by showcasing some AI prompts. First, I'm going to create a sales order with a purchase order reference value. When I trigger a prompt, create a sales order for this customer, it connects to the backend system via a destination service using OAuth authentication. The agent is now attempting to connect to the backend to verify if the existing values are valid, and then proceed to create the sales order. As you can see, our agent created a sales order with the required inputs and displayed it as an output. Now I'll add line items. I have these 2 line items that I want to add to my sales order. Since I already created a sales order with ID 124, I'm replacing the sales order ID to add these items. I am now triggering the prompt to add materials with a quantity of 1 to sales order 124 at plant 1710. Our sales agent is now checking if the sales order exists. If it does, it will add the material to the existing sales order. We can see it's adding the first item to sales order 124, and now it's adding the second item to sales order 124. It's refining the results, and here's the confirmation of the sales order it created. So far, we've covered post operations, specifically creating a sales order and adding line items. I can also perform update operations on existing sales orders. Let me demonstrate an update. If I try to update the delivery date for sales order 124 to October 10th, the system will check if sales order 124 exists. If it does, it will update the delivery date to October 10th based on the value provided in the prompt. As you can see, it's performing that update operation for the delivery of the sales order. An update to the delivery date has occurred for the existing sales order. These are examples of the post operations we can perform via the conversational AI tool. Now, if I want to check for any sales orders with a credit block, I can simply ask, are there any credit blocks for sales orders? When I hit this prompt, the system will check the back end to see if any existing sales orders have a credit block. If so, it will report them as blocked sales orders under the credit block section. It is now checking the credit block status for existing sales orders. As I mentioned, we also have the governance dashboard where we can define policy engine rules related to the net amount, which we've configured as a sample. If you look at our governance dashboard, We've already defined a release threshold control of 990 as the current net amount threshold. This means if any sales orders have blocks, and we want to release them, either manually via conversational AI or automatically via the scheduler, the system will check these conditions. If a sales order's net amount is less than or equal to 990 USD, it will be auto-released without needing business approval. However, if it's greater than the configured value of 990 USD, it will trigger a notification stating that business approval is needed to release this sales order. Returning to the demo, when I asked about credit blocks for sales orders, the agent displays the sales orders that have a credit block. It's showing a delivery block as partially blocked with credit limit. Notice that the release eligibility is currently showing as not possible. This is because our configured threshold is 990 USD, but the net amount of this order is higher than that. If I want to dynamically change this for ad hoc intermediate business requirements, I can do so without redeploying any code. Let me show you. There are sales orders with different net amounts. I will now choose a configurable value that will make the release eligibility yes. What I'm going to do is set the configurable value to 11,000 USD. I will update the threshold. As you can see, the threshold has been updated. Now the system will show auto-release based on the value we configured. If the value is less than or equal to this threshold, it will release the sales order automatically. If it's greater, business approval will be needed. Now we'll check for sales orders with credit blocks again. When I hit this prompt, for sales order ID 4, it will now show that release is eligible. This is because the configured net amount threshold in the governance dashboard is now much higher than this particular net amount. I'm hitting the prompt again. Are there any credit blocks for sales orders? Let's see how it reacts dynamically. We haven't done any code redeployment here. Everything is changing dynamically. As you can see, it's gathering credit block information. And as we mentioned, we updated the dynamic thresholds in the agent governance dashboard. Based on that, the code dynamically adapted. And now for the prompt I re-triggered, it's showing release eligible yes. We can now release the sales order using conversational AI in a dialogue manner, or we can observe how our Zyntralynk agent governance dashboard autonomously releases that specific sales order. Currently, we have this governance dashboard where the scheduler runs every 15 minutes. To trigger the next run, we'd normally have to wait another 10 minutes. However, if there's a business requirement to immediately release sales orders autonomously in a batch mode, instead of doing it manually via conversational AI, we can use the autonomous scheduler. This allows for ad hoc runs in addition to scheduled ones. Let me trigger a manual run. When I click on manual and go to the command center, you can see the status is running. If I refresh the screen, the job is still running. Now, out of 5 sales orders, 1 sales order was released and 4 failed. The dashboard confirms this. Out of 5 sales orders, sales order 4 was eligible for release and was released by the autonomous scheduler, while the rest failed to release. This is because they failed due to the net amount threshold we configured, which was higher than their respective amounts. To prove this, once the Zyntralynk agent governance dashboard releases sales orders that were in a block state and satisfied the dynamically configured business rules, it sends a report. This report shows that out of 5 blocked orders, 1 was successfully released and 4 failed. The one that was delivery blocked was released, and it explicitly states released. For the others, it clearly mentions the reason. The order is blocked because the net amount exceeds the configured threshold. Please check with the business team to proceed. In this way, the Zyntralynk Agent Governance Dashboard can communicate externally to end business users, notifying them about blocked sales orders that require business attention. Our governance dashboard also includes live telemetry, which shows what the scheduler is doing in scheduled mode. It also shows information for any ad hoc runs you trigger. With live telemetry, if something goes wrong within the system during release, it will show you why it failed. You can check the live telemetry here to see what happened to a particular sales order ID when it was being released autonomously by the agent via the scheduler. This provides more meaningful information and guides the next steps. We can also perform health monitoring for all our AI agents. To check the health of each agent, you can click Check Now on each agent's dual skill. If you want to check them all at once, you can click Check All Agents, which will check the status of each dual skill. Additionally, you'll see various options here, including the uptime of each dual skill, when it was last checked, if a circuit breaker is open, and if there are any failed cases. If a drift score exists, the circuit breaker is in an open state, meaning there were failed calls. The drift score is calculated as total failed calls divided by the number of calls, 100. So for every agent, it calculates the number of calls, drift score, the last time a healthy status was checked, and the agent's uptime. You can see all of this observability data related to the sales agent. You can also trigger prompts directly from the agent governance dashboard. If I want to see a sales order, I can ask Get Order 1, and it will show me the details about Sales Order 1. This demonstrates how you can provide prompts in a more natural language, rather than rigid statements, and the system will understand and provide meaningful output from the Agent Governance Dashboard. It can handle all lifecycle operations for the Sales AI agent. Whatever actions you can perform from the conversational AI in dialogue mode, you can also perform autonomously via the scheduler. This concludes the demonstration of our governance dashboard and the live demonstration of our sales AI agent. Regarding the technical architecture, this AI agent securely connects to the SAP backend through an OAuth-protected MCP server. The governance dashboard manages